Alright guys, today we're going to look at a new kind of graphing. So everything that you've done up until this point has been graphing on a normal coordinate plane with all of your points in the form of x comma y. And that was what was known as rectangular coordinates. Now what we're going to switch to is something called polar coordinates. And polar coordinates were different in that instead of being an xy point, they're going to be listed as an r comma theta, where r stands for the radius and theta is an angle. So you've already drawn angles like this before. Let's say I wanted to graph a 45-degree angle. I would start with my initial side, end with my terminal side, and that's 45 degrees. Well, I can still do that. That's my 45. That's my theta. The only thing I'm going to incorporate now is I'm also going to go a certain distance away from that center point. And that distance away that I go, for this case it's 4, is my r. So r is how far away from the center, or what we call the pole. So to graph this first point, I'm going to graph 4, 5 pi over 3. To start that, I'm going to go to the angle 5 pi over 3. Now this spiderweb looking thing over here on the right, that's polar graphing paper. Now each of these little circles on the inside represents a distance of 1. So to graph this first one, I would go to the angle 5 pi over 3, and from that angle I would move out 1, 2, 3, 4. So my dot would be right there at that point. And I'm going to erase the rest of it because we don't really need that on the graph paper. It's just to kind of help us figure out what to do. Now if you don't have the graph paper, it's okay, because a lot of this we've actually done before. We're used to graphing those angles with those 0, pi over 2, pi, and 3 pi over 2 lines marked. We just don't have that paper behind it, and that's okay. So if I don't have that paper, I would graph this line like this. I would draw the angle. I'd have an initial side, and then 5 pi over 3, I know ends in the fourth quadrant. I can draw my arrow. And then from that center, I just label 1, 2, 3, 4, and that's how far I'm going out. Now if it makes it easier for you and you want to draw those normal lines you're used to, that's okay, you can still do that. Just make sure you label that 4 that you're going away from the center. Alright, so now if I move on to Q, Q is going to be at the angle 7 pi over 6, which I know is in the third quadrant. And from the center, I'm going out a distance of 3. So there's point Q. R is a little bit different, because as you notice, the radius there is negative. So what that means is I'm going to start at the angle 5 pi over 4. Now 5 pi over 4 is not labeled, but we know 5 pi over 4 is in the third quadrant. It's going to be in between the reference angles of 30 and 60. So I can see which line is going to be 5 pi over 4. Now, the difference here, though, is instead of graphing on that angle, because my radius is negative, I'm actually going to go backwards 2. So I'm going to go 180 degrees in the opposite direction to plot my point. So a negative radius, I'm going in the opposite direction to plot my point. Now the way I would graph this without graph paper, I would go ahead and graph my 5 pi over 4 angle, but I'm going to make it a dotted line because I'm not actually going to 5 pi over 4. Instead, I'm going backwards from it, and I'm going out a distance of 2. Now if you want to draw your arrow, you still can. The arrow would just go to that positive, or to that dotted line. Now one thing to look at again is where this point is drawn. That angle is at pi over 4. So I actually could list this exact same point with a different name. If I wanted that to be a positive radius, I could, but instead of 5 pi over 4, it would be 1 pi over 4. And again, just like we learned with coterminal angles, there's an infinite number of ways to write that one point, depending on how many times you go around that circle. I also could add a 2 pi and make that 9 pi over 4, which is equivalent. Now the last one I have is a negative angle, not a negative radius, and that's different. We've graphed negative angles before. We still start at 0, we just go backwards in the opposite direction, pi over 3. So in this case, instead of graphing pi over 3, I'm actually graphing 5 pi over 3. And again, those are coterminal angles. So at that angle, I'm going out 1, and at that point, I'm labeling my coordinate. So now what we're going to look at is how to differentiate between, or how to switch between my rectangular and polar coordinates. So there is a way to switch back and forth between them, and what we're going to start with is a picture that we've actually looked at a lot. So what I'm going to do is I'm going to draw some random point out here. Now we know with that point, the distance to the center is my r. We know the distance up and down is y. And the distance side to side is x. We know that makes a 90-degree angle, and that reference angle there is theta. So then using that picture, I can fill in this chart over here. The cosine of theta is my adjacent over my hypotenuse. So if I want to solve that equation to get x by itself, I could pretty easily. I can just multiply both sides by r, and I get that x equals r cosine theta. I can do the same thing for sine. It says that sine is my opposite over hypotenuse. If I want to get y by itself, just multiply both sides by r, or cross multiply, and I get that y equals r sine theta. Now those two equations I just came up with are actually how I can convert my polar coordinates to rectangular coordinates. Because if I have an r and a theta, this is how I can get an x and a y from those. This also helps us understand a little bit better when we've talked about how x always relates to the cosine function and sine relates to the y function. You can kind of see where those come from now. All right, the next one on here is tangent. So my tangent function is opposite over adjacent, which is y over x. Then I have x squared plus y squared. And if you look at our picture on the Pythagorean theorem, x squared plus y squared is r squared, which means r just by itself is the square root of x squared plus y squared. So now we're actually going to take an example. Oh, sorry, I forgot to tell you guys, those last numbers, those are how we go the other way. That's how we go from rectangular to polar. So now if I go the other direction, okay, let's say I want to actually convert those points to rectangular coordinates. I'm going to use those top two formulas I came up with. So the first thing I'm going to find is my x value. My x value is going to be r times the cosine of theta. Well, I have an r and I have a theta value right there. That means my x coordinate is 4 times the cosine of 5 pi over 6. So all I have to do is evaluate the cosine of 5 pi over 6. We went over exact values again for this reason. So I'm going to draw 5 pi over 6. It's in the second quadrant. The reference angle is 30. That means my adjacent over my hypotenuse is a negative root 3 over 2. And when I multiply that together and simplify it, I'll get a negative 2 root 3. So that's my x coordinate. Now to find my y coordinate, I'll do it the same way. My y is equal to, according to that formula up there, r sine theta, which means that my y coordinate is going to be 4 times the sine of 5 pi over 6. And because it's the same angle, I already have my picture. So it's just going to be 4 times my opposite over hypotenuse, which is 1/2, which means my y coordinate is 2. So that means my equation here, my final point, remember it's an x comma y for our final answer, which means that I get negative 2 root 3 comma 2. Alright, so now we're going to work the other way. We're going to take rectangular coordinates and turn them into polar coordinates. So the very first one we're going to do, if you remember those formulas we just went over, we said that the tangent of theta is equal to y over x. So on this first example, that means that the tangent of theta is going to equal negative 1 over the square root of 3. So we're doing an inverse value. Now the question here is which quadrant to draw my picture in. I know tangent can be negative in both the second quadrant and the fourth quadrant. But since to figure out which one to use, I look at my original point. My original point is positive square root of 3, negative 1. Well, if I go over to a positive value and down to a negative value, I have to be in the fourth quadrant. So I'm going to evaluate that theta in the fourth quadrant. So I've got an opposite of 1 and adjacent of root 3 with a Pythagorean theorem. I'm missing sides 2. So that means my reference angle there is pi over 6. So if the reference angle is pi over 6, that full angle all the way around in my theta has to be 11 pi over 6. And the reason we want 11 pi over 6 instead of negative pi over 6 is because it tells us at the very top that we want theta to be between 0 and 2 pi. So now we just need to find our r, which is a little bit simpler. So it says that r, we know that x squared plus y squared is equal to r squared. So all I have to do is take my x and square it, take my y and square it, and it's pretty easy to see that r is going to be 2. So that means my final answer here is going to be an r comma theta value. and that's the equivalent coordinates. All right, we're going to skip B, and we're just going to move on and do letter C. Now C is actually going to be easier if we just think about this for a second and look at our picture than if we go through and work out all these formulas. If I plot the point 0, -2 on a regular coordinate plane, that is that point right there. Well, in order to write it as a polar coordinate, we need an r and a theta. Well, it's really easy to see the r, I've gone 2 away from the center. And then theta is how much that angle is. And we know that angle is 3 pi over 2. So sometimes there's shorter ways of working these out. All right, now the last thing we're going to do is we're going to convert equations. So when we're converting equations, we're really just going to substitute things using those original properties we came up with on that previous part. So for example, when we're converting from a rectangular equation to a polar equation, our goal here is to get rid of x's and y's and only have r's or thetas. So if we're converting this to polar form, that means there are no x's or y's. So I need to see what I can substitute here. So if you go back to the formulas that we just put in, we know x is the same thing as r cosine theta. I got rid of my x's. Now if you wanted to get r by itself, you could. You'll see a lot of these equations as r by itself. So if you wanted, you could rewrite this as 3 over cosine theta. But what's important here is that you're getting rid of your x's and y's. All right, then this next one here, again, if we look back at that chart, we can see x squared plus y squared is the same thing as r squared. And if r squared is 16, r has to be 4. Now again, this is another one that we'll talk about more when we look at our graphs. But x squared plus y squared equals 16. We know that's a circle centered at the origin with a radius of 4. If you think about r equals 4, that means no matter what angle I'm at, I'm exactly 4 away from my center. And that's exactly what we just drew. All right, now the last thing we're going to do is we're going to convert these equations to rectangular form, okay, from polar. So again, we're still going to replace things using those same equations. And that first one should look pretty similar. R cosine theta can easily be replaced like we just did before with x. So r cosine theta is the same thing as x equals 3. And we know that just looks like a straight vertical line. And let's look at this last one. We'll go ahead and do C. So I know that theta equals pi over 3. Now if I look at all my different theta equations I have, the only one that doesn't use r is tangent. So I know the tangent of theta is equal to y over x. So that means that the tangent of pi over 3 is equal to y over x. And then that means I can actually evaluate the tangent of pi over 3. That's a 60-degree angle in the first quadrant, which means my opposite over hypotenuse, opposite over adjacent, is going to be the square root of 3. And then with normal rectangular coordinates, we're used to getting y by itself, and that would be easy, just multiply by x. So I get the equation y equals the square root of 3 times x. And again, this is another one that's good to make sure we understand it. Y equals the square root of 3, that's just a straight vertical line. So it's a vertical line, or not a vertical line, it's a linear function with a slope of the square root of 3. If you think about the equation theta equals pi over 3, that means no matter what my r is, my r could be 1 or 2 or 3 or 7, or it could be a negative value. No matter what those r's are, I'm staying at that same angle. And that's just a straight line. Alright guys, tomorrow we're going to look more at actual graphs using these polar coordinates. And then from there you'll see some of the different graphs that we can make.